All right, how's it going, guys? We're back with our second to last video, just one more after this one. This one is, it's a bit of a departure because it's on the unit step function, and this really doesn't have anything to do with Laplace transforms at all, so it's a bit of a sort of interjection. This is more of a notational thing. And because of that, there's no real prerequisites for this. Maybe that you know how piecewise functions work, but again, that's just basic algebra, and that's a long time past. So let me tell you what the unit step function is. Okay, and there's many ways to notate this, but the one your book uses notates the unit step function as u sub a of t, and this is a piecewise function. Okay, this function is equal to 0 as long as t is somewhere between 0 and the value a. And then it's 1 as long as t is greater than or equal to a. Okay? That's it. Okay? So let me draw this and I'll explain to you what this actually does. Okay? So I've got, all right, I got a function here. Guess I really only need the one range value, 1. And somewhere along this x-axis, we've got the value a. Okay? All right, so it's a very simple piecewise function, right? It's 0 until I get to a, right? So it's 0, it's 0, it's 0, it's 0, it's 0. Okay? And then when I get to a, it jumps up to 1. That's it. It's not overwhelmingly complicated, right? So, but why is this such an interesting function? Well, other than the fact that it has a very nice Laplace transform, we never look at this function by itself. We always look at this function, or functions like this, we'll talk about a few other forms, with their products with other functions. So for example, let me take a look at the following function. So let's say I have f of t, and f of t is t minus 2 squared, right? So that's just a parabola. That's a normal parabola. It's shifted to the right 2 units, yeah? And we know what this looks like. But the one I want to look at then, I want to look at this function. I want to look at what is u sub 1 of t times f of t, right? Well, let's think about this for a minute. For every value of t, which is less than 1, remember, u sub a is this value here, a is 1. For every value of t less than 1, isn't this 0? Yeah? Isn't this 0? So if I were to write this as a piecewise function, I can say that when t is between 0 and 1, again, there's the a value, 1, this is 0 times f of t. That's just 0. But when t is greater than 1, it's 1 times f of t. That's just f of t. So a better way to think about these unit step functions is to think about them like they're switches. They turn functions on and off, right? u1 of t, if you multiply a function by u1 of t, what you've done is you've turned that function off until you get to 1, right? And then it turns itself on, right? If you want to keep it off until you get to 5, you multiply it by u5 of t, right? u sub 5 of t will be off until you get to 5 rather, and then it'll be on again, right? So if I wanted to graph this function here, okay, if I wanted to graph this function, well, okay, let's see what I have. Okay, I've got, there's 1. Now I know what my parabola would normally look like. My parabola would look like this. But because I'm multiplying it by u1 of t, what I know here is that this thing doesn't turn on until I get to 1. Everything to the left of 1 has now been zeroed out. That's my new function, right? My new function, it's 0, it's flatlined, it's nothing until you get to 1, and then this thing is now turned on. Now it just looks like my normal f of t, okay? Now, so this is one switch. This switch starts off and then eventually turns on, okay? In order to write all of my piecewise functions, I'm going to need 3 types of switches, okay? I'm going to need functions that are off and then on. I'm going to need some functions that are on and then later on turn off. And I'm going to need some functions that are off for a while, excuse me, then on, then off for a while again. Okay, so let me see if I can't write those down. So what I have, I've got 3 types of unit step functions. Here's one of them, okay? So something of the form u sub a of t. This is off and then on. So if you multiply something by u sub a of t, you're going to get nothing, and then once you hit that value a, it turns on, and then it looks like whatever function you multiplied it by, right? Okay. What about 1 minus u sub a of t? Okay, so let's think about this. So again, the sort of central value here is a, right? And if I'm to the left of a, isn't this 0? If I'm to the left of a, this is 1 minus 0. 1 minus 0 is 1. This is 1. Until I get to a. And then once I get to a, what happens? Well, once I get to a, this value is now 1. So it's 1 minus 1, which gives me 0, right? So this function is on and then off, okay? Right? So basically this gives me the right section of a function, this gives me the left section of a function, okay? And now what I really want is, let's say I want something that for 2 values a and b, I want to figure out how to do this. Right? So I've got, it's on until I get to, it's off rather until I get to A, then it's on, and then once I get to B, it turns off again, okay? This is maybe not as somewhat obvious as that one. This is u sub A of t minus u sub B of t, okay? Again, let's sort of reason through why this works. If I pick a value to the left of A, well, if that value is to the left of A, it's certainly also to the left of B, right? And so if it's to the left of A and to the left of B, then both of these are 0. That's 0 minus 0, so my function is equal to 0. Fine. What if I pick something between A and B? Well, if I pick something between A and B, then it's to the right of A and the left of B. That means this function will be 1, and this one will still be 0. So it'll be 1 minus 0, that's 1, see my function is 1. And if I pick something to the right of B, then it's to the right of both values, and then these functions are both 1. And 1 minus 1 gives me 0 again, right? So using switches of these forms, these 3 forms, I now have a way to rewrite piecewise functions, okay? I have a way to rewrite piecewise functions. These give me an alternate notation for piecewise functions. I'm going to do a couple of examples here to show you how that actually works. The good news is there's actually a very nice formula for the Laplace transform of the product of a unit step function and a normal function. That's why we're doing this, right? So being able to rewrite my piecewise functions in this form is going to allow us to use our Laplace transforms on piecewise functions without all that messiness of having to integrate piecewise functions and do a bunch of other nonsense. Okay? All right, so copy these down. Right now, pause the video, copy these down in front of your notes because I have to erase them, but I'm going to refer back to them as I'm doing these examples. Okay. Okay, so let's take a look at a piecewise function. Let's see. That looks fun. Okay, so let's do f of t is equal to t when t is between 0 and 4, and it's equal to t squared minus 2 when t is greater than 4. Okay. All right, so let's see. If I'm graphing this, here's what I've got. Okay? If I'm graphing this from 0 to 4, this looks like a line. I mean, specifically, it looks like the line f of t is equal to t, right? It's a line, slope 1, right? After that, it looks like a quadratic, okay? So after that, it looks like a quadratic, and it's a quadratic shifted down to, so it'll actually be up here, right? And so what I want is, I want to somehow operate on the left-hand side. I want this to be the function f of t equals t, right? And then when I get to 4, I want to turn this function off, right? I want to turn this function off at 4, and then right here, I want that to be f of t is equal to t squared minus 2. So at 4, I want to turn this one on, okay? All right, so we look back at our notes and we ask ourselves, okay, so which switch is on first and then off? And that's this one, okay? That's 1 minus u sub 4 of t, okay? This switch, whatever function I multiply that by, this switch is on until I get to 4, and then after that it'll disappear. Won't exist anymore, right? And so the function I want is t. Okay? I want t, I want to see the function t until I get to 4, and then I don't want to see it anymore, right? And at 4, I want to start seeing this function. I don't want to see t squared minus 2 until I get to 4, but once I get to 4, that's what I want to see. So what I'm going to do is I'm going to add u sub 4 of t times t squared minus 2. So if I'm less than 4, if I'm right here, let's say I plug in 2. If I plug in 2, this doesn't exist, right? If I plug in 2, this function doesn't even exist. So that's gone, and it's just going to be t. But if I plug in 6, something to the right of 4, if I plug in 6, this won't exist. And so it's just going to be this function, right? So this is my piecewise function. This is f of t, right? So this is f of t. Now, unfortunately, I got to do a little bit more than this because my Laplace transform is really going to want my Laplace transform is really going to want my common unit step functions grouped together. That's not a huge deal. I just need to maybe do a little bit of algebra here. Let me distribute this t. I get t minus u sub 4 of t times t plus, I've got u sub 4 of t times t squared minus 2. And notice these are both u sub 4 of t terms, right? So I've got a t squared minus 2, I've got a negative t here. So I've got t plus u sub 4 of t times t squared minus t minus 2. Okay, and let me just color code this a little bit. Sometimes it's kind of hard to see where stuff goes. Clearly the t squared minus 2 came from there, but the minus t came from minus t, right? So that's minus t, and then t squared minus 2. All I did was factor out the u sub 4 of t, right? So t squared minus 2. Okay. Yeah. So really, this is the form. That I'm going to want to work with whenever I do my Laplace transforms. Okay. All right. So this is fine, right? And in general, okay. So in general, this will always be the switch for your leftmost piece. Okay. So your leftmost piece. So right here. This is always leftmost switch, and this will always be your rightmost switch. And you'll only ever have one of each of these, no matter how many pieces your piecewise function has, right? Because you'll have one piece on the left, one piece on the right, and everything else qualifies as some piece in the middle, right? So you'll only ever have one of these. And if you look on your, again, I told you to write down the switches. If you look on those switches, you'll notice that I've got one for that middle switch. That one's going to get used as many times as you have middle pieces. Okay, so let me do an example of one with a middle switch real quick here, just to make sure I hit an example of all of them. Okay. All right. I should point out these things also go by the name Heaviside functions, but I don't know. I don't like this. I've always called them unit step functions, so, whatever. All right, here we go. Here's a good example out of your book, and this one's got a lot of pieces to it, right? All right, so I've got f of t is equal to, here we go, got 4 pieces. T, -1, t minus 4, and e to the t. Okay, and the first one, this is when t is anywhere from 0 to 2. The second one, t is anywhere from 2 to 4. The third one is from 4 to 5. And then after 5, it's always e to the t. Whoa, okay. So real quick, again, let's label. So this is the left piece. This is the right piece, right? And I know how to write those, okay? I know how to write those. My left piece, I look at the endpoints here. So these are important. Okay, so these are the important numbers here. So I look at the endpoint here. So my left piece, that's 1 minus u sub 2 of t, and times my function here, t. That's my leftmost piece. Okay? My rightmost piece, okay? My rightmost piece, that's all the way over here. You know what? I'll put this in another color. Okay? My rightmost piece, that's going to be, again, this one. Look at your key point here. 5. So I'm going to put this all the way over here because it's all the way on the right. Okay? So plus u sub 5 of t times e to the t. Okay? So again, this is the form for the left piece. That's the form for the right piece. Now, how do I do the middle ones? Okay. So if you remember, okay, the middle ones are done by taking the difference of 2 unit step functions. So let me do this one next. So here's my function. My function is -1, and I want it to turn on at 2 and then turn off again at 4. And the way I do that is I use u sub 2 of t minus u sub 4 of t. and then times my function, -1. Okay? So this is one of my middle functions. And every middle function has this same form, right? So, that said, this is also a middle function. Okay? Again, using these, so plus u sub 4 of t minus u sub 5 of t, oh man, running out of room, plus u sub 5 of t, and I'll multiply by my function here, t minus 4. Okay? All right, so this is my function. Okay? So again, I've sort of color-coded where all these things come from, the left, the right, both the middles. But again, I got to do some rearrangement. I can't really take a Laplace transform of this, right? So I'll need to rearrange it. This is f of t, though. This is a perfectly acceptable alternate notation for f of t. But in the interest of preparing ourselves for section 10.7 and doing Laplace transforms using the second shifting theorem, I do want to regroup these things to where all the common unit step functions are together. See, I've got 2 u sub 2's, 2 u sub 4's, 2 u sub 5's. So let me go ahead and do some distribution here. This is t minus u sub 2 of t times t minus u sub 2 of t, distributing the -1, plus u sub 4 of t plus u sub 4 of t times t minus 4 minus u sub 5 of t times t minus 4 plus u sub 5 of t times e to the t. Okay. All right, fine. So let's go ahead and factor some stuff out here. So I've got, I've got t. These two terms, I'll factor out u sub 2 of t. So plus u sub 2 of t times -t minus 1. You can factor out the negative if you want and make that t minus u sub 2 of t. It doesn't really matter. Okay. From these two, here we go. I factor out u sub 4 of t. It's going to leave a t minus 4 here. It's going to leave a positive 1 here. So t minus 4 plus 1 is t minus 3. Okay. Again, I'll have t minus 4 from this term, and I'll have just a positive 1 here, and t minus 4 plus 1 is t minus 3. And then finally over here, I've got my 2 u sub 5 terms. So factor out the u sub 5 of t, and that gives me e to the t minus t plus 4. Again, I'll factor out u sub 5 and then distribute the negative sign into this term here, right? So this is what I'm really going to want, okay? This is the one I'm going to want to take a Laplace transform of. That's fantastic, right? Yeah. So this is not overly terrible. Again, there's no problems associated with this. This is just, this whole section might be like 3 pages long. And again, the sole purpose is just to get you to be able to write piecewise functions in a form with Heaviside step functions, or realistically be able to go backwards as well. That's not really that bad either. Okay? All right. I will see you guys next time. We've got one more lecture. Please make sure you're doing your homework as normal. All the homework is already posted on Canvas, or online in case this video is being viewed years from now when we're not using Canvas anymore. But your homework's been posted online. Please make sure you go through and do those problems, and I will see you next time.